Okie dokie.
So welcome everyone to the 25th webinar for the Montana Accessibility Interest Group. We're really fortunate to have Aaron Page join us as our guest speaker. Again, this is his third time providing information for us on math accessibility and the progress that's being made there. Aaron's a part of this group and regularly attends the meetings. He works internationally to improve the accessibility of systems like reading systems, web conferencing systems, this very system that we're using, Collab Ultra, and the accessibility of Moodle and Moodle rooms. So Aaron has a lot of background in math accessibility and is going to talk for the first time today about chemistry accessibility as well. So welcome, Aaron. I will turn it over to you. Thank you for being here.
Awesome. Well, thanks for inviting me, and thanks everybody for joining the session today. So as Marlene said, we're going to talk a little bit about some updates in math accessibility. So the last time I gave this presentation for the Accessibility Interest Group was August of 2015. So it's been a little over a year. There's been some pretty amazing developments that have happened just in the past year. The past 2 years have truly been amazing in terms of math content accessibility. So I created a series of web pages that I'm going to be using, essentially like a PowerPoint slide, but in order to have accessible math content within the pages, I set them up as actual web pages. Marlene's going to put that URL into the chat for you guys. Please feel free to pull up the web pages and follow along as you would like. There is one section, the very last item that we're going to cover is going to talk about chemistry and some updates in Moodle that make chemistry equations accessible or chemistry formulas accessible. That is not in the pages. So that's the one part of this that you won't necessarily be able to follow quite along with, but you'll be able to see that on your screen. And there is zoom and scrolling controls within Collaborate if you're having any trouble seeing in order to follow along. So as you guys should be able to see, I should have application sharing on. You should all be able to see my screen. So this is just the intro page for the site that I've set up here. And so there are 9 items, 9 subpages essentially that we're going to go over here. So the first one is going to be, we're going to review some key terms just to make sure that we're all on the same page. These are terms that I'm going to be using quite a bit throughout the entire presentation. So it's good to just make sure we all are following along with that. I'll also mention real quick too, if you have any questions, please feel free to type those into the chat. We're going to hold the questions till the end though, just because there's quite a bit here to get through. So, but if you have questions, please feel free to type them into the chat, and then at the very end, we'll go looking through the chat and catch up with all those messages. So the second item that we're going to cover is online math content delivery. So there are really 2 main ways in which you tend to find equations and math content provided online in a manner that is accessible, and each has its own advantages and disadvantages, and so we're going to cover those. Item number 3 is going to be an LMS comparison. So the 4 big players, Learn, Canvas, Desire to Learn, and Moodle. We're going to talk about which of those content delivery mechanisms that particular LMS chose to go with. Then we're going to move on to math at U of M, at the University of Montana here, how we chose to do it. We think we're just about ready to finalize an official process for how we go about creating alternative formats of math. So I'm going to describe that process and some of the reasons why we chose to do it the way that we're doing it. I will say I don't think that's 100% finalized, so anything can change. And then we're going to get into some actual updates in assistive technology. So we're going to cover JAWS, and you may notice at the end of each of these items in the table of contents, I have these just little phrases that I had fun coming up with as I was putting these pages together. So JAWS, it says bring on the Braille. So we're going to talk a lot about the Braille functionality that JAWS has got now. We'll talk about some updates with non-visual desktop access and the free Math Player plugin that's provided by Design Science. We'll talk about Narrator and Microsoft Edge. This is kind of a new area. Really up until Windows 8, Windows 10, Narrator was no-go zone for advanced screen reader users who really depended on the screen reader to operate the computer. And then Microsoft Edge is their new browser. Some of you may or may not be familiar with it. We're going to talk about the math accessibility that's supported by Narrator with Microsoft Edge. Because, of course, that's what Microsoft wants you to use. They want you to use their screen reader and their web browser. Then we're going to talk a little bit about Math Support Finder and MathML Cloud. These are two products that came from Benetech. I don't know if Sue-Ann managed to join us, but Sue-Ann, if when we get to that, if there's anything you'd like to mention, please feel free to speak up. Then we're going to do the chemistry in Moodle. So that I put down as a bonus, since it's kind of not math, it's chemistry, but it's powered by math. It's a lot of the same technology. So I hope you guys find this interesting and useful, and let's go ahead and get started. So I'm going to go ahead and hit next here. We'll go to the first page. Okie dokie. So the first key term that we want to talk about here is MathML. So for those of you who are not familiar with it, MathML is a markup language, just like HTML is hypertext markup language, MathML is math markup language. So essentially how HTML is used to create most content that you see on a web page is generated by HTML. The layout of it tends to come from CSS, but the content itself is HTML. And so MathML looks very similar to HTML. It uses a lot of the same looking starting and ending tags and brackets, or I'm sorry, in left and right. I can't remember what you call those, to be honest with you now. Left and right pointed arrow looking guys on the period and the comma keys. So there's a sample of MathML code that I've inserted here into the page just so you can actually see what some MathML looks like. And so you can see here it opens up with MathML, XLMS, whatever that is, referencing the specific standards for MathML, that specific version of MathML that's being referenced here. And then you can see these MRow lines here, MStyle. This is all required for this MathML equation to work. And so you can see there's lots of lines of code here. If we get down to the bottom of that here, you can actually see what that equation appears as. So that all of that MathML code that you see there forms this one equation of f of x equals subscript, superscript x. So I'll go ahead and let Jaws read this out for you guys so you can actually hear that. Probably should turn the speech rate down for you. For any of you who are curious, the speech rate that you're hearing right now is the normal speech rate that I tend to operate Jaws at. Let's turn this down here.
20% enter. Aaron M.
Okay, so all of that MathML code that you see up there is this one equation.
F left parent x right parent equals subscript to superscript x f left parent t right parent dt. Blank.
So all of that to form the one single
Heading
equation.
level 4 LaTeX.
So the next key term is LaTeX. My understanding of this is that you can pronounce it either as LaTeX or LaTeX. Either is appropriate.
Blank.
So LaTeX is
Left parent could be
another
pronounced
essentially
LaTeX.
markup
Left
language
parent could be pronounced
that
LaTeX.
is used by scientific content authors, math content authors. The trick between LaTeX and MathML is that LaTeX can actually be used to structure an entire document, including the format of it, the layout of it, how things are positioned and sized and whatnot. So it essentially includes what in HTML is HTML, CSS, and MathML. All is contained within one thing in LaTeX. And that's part of the reason why it can be kind of difficult to go convert directly from LaTeX to MathML, is because it's not just the equations, it's not just the math content. It can actually include just regular old text content, tables, pretty much anything can be authored up in LaTeX and then saved out in like a PDF form.
Simple definition, commonly blank.
And then the third one
MathJax heading level.
is MathJax. So for those of you who are not familiar with MathJax, MathJax is a set of, it's a JavaScript engine that uses type font, CSS, or JavaScript in order to take what is MathML or is LaTeX or ASCII math and display that visually out on the page. MathJax provides some additional benefits to it that you don't necessarily get from using like pure MathML. So for example, with MathJax, you'll get a very consistent appearance across browsers because it's not the browser taking the MathML and rendering that out visually. It's actually just responding to the CSS and the type font that's used by MathJax. And so you can see, excuse me here, you'll see the equations appear the same regardless of whether you're in Internet Explorer, Firefox, Chrome, versus a pure MathML equation that has just been embedded into the page could actually look a bit different depending on which browser you're in, and some browsers just don't even have support for MathML being inserted directly into a page. MathJax provides some additional benefits such as the ability to zoom into equations, the ability to copy and paste equations into other applications like Mathematica, Microsoft Word, you name it. For assistive technology users, MathJax actually provides a hidden MathML layer that say for example, a screen reader will interact with. So technically speaking, you could say that there are two equations that are on a page that is using MathJax. There's the MathML equation, which is not being displayed, but is accessible to a screen reader. And then there's the CSS equation that is generated by MathJax. That is what non-disabled, non-assistive technology users will see and will interact with.
Simple hidden blank. List of 4 MathJax sample page heading
And
level.
so I will
blank
go
with
ahead and
heading
pull up.
level
I just
5
put a
link
link in
MathJax
here
sam
to the
enter.
MathJax
Area
sample page.
MathJax-Mozilla Firefox read.
So you can see some of these other equations that they've got
Making
here.
meta quadratic formula
So
heading.
here's like the
blank.
quadratic formula.
X equals fraction, negative b plus or minus the square root of b squared minus 4c over 2a. Math content clickable. Cauchy's integral formula heading left blank. F left parent the right parent equals 1 over 2 pi I contour integral sub gamma fraction. F left parent z right parent over z minus a. dz math content clickable.
It's astonishing to me that some people can understand these equations. So that is what MathJax is. And MathJax, we're seeing more and more now being used in LMS platforms and in some other applications as well. So go ahead and go
Title
back
is math
to page here, and we'll move on to our next
links
item.
list dial N. Next enter. Aaron M page updates and math accessibility heading level 1.
Go ahead and plug the headphones back in here so you guys aren't listening to the screen reader the whole time. Okay, so math content delivery. So there are really two big ways in which you tend to see things like equations and formulas being provided out on the web. And those two techniques essentially are MathML, whether that's being done as just pure MathML that's been inserted into a page, or it's coming from something else like, say, MathJax, which may be rendering it from ASCII or from LaTeX. So there's MathML. And then there is also images with alternative text descriptions. So essentially what that is it's a picture of the equation that has the text, the wording of how you would read that equation out, inserted into it as alternative text. So each of these techniques provides some benefits. So let's see, sorry, I got my JAWS focus out of the way there. So with the embedded math content, so you get access to the full math functionality that's provided by a specific assistive technology. So for example, JAWS has this feature that it calls the math viewer that allows you to navigate by term or by expression. And when an equation is pure MathML, or is MathML coming from like MathJax and is recognized as math content, then that additional math functionality provided by the assistive technology becomes available. And so the same goes for like non-visual desktop access, the ability to zoom into portions of a particular equation, or if you're using a program like Read and Write Gold that has support for reading MathML content. It can be accessible in both speech and Braille when combined with an external Braille display. This is really fantastic. So one of the amazing statistics that I heard while I was a student, I was sponsored by Vocational Rehabilitation to attend the University of Montana, and my VR coordinator made a comment to me at one point that getting accessible math text, getting a math textbook converted into Braille, on average can cost over $10,000 if you're talking about a math text that's used in higher education. So they can be very, very expensive, and then it takes forever to produce it, and the result is usually a dozen or more multi-inch thick Braille books that you essentially have to use a trolley cart in order to carry those books around with you. Whereas with MathML content, using a compatible assistive technology like JAWS or NVDA or VoiceOver, they can actually provide that equation in Nemeth Braille Math on that refreshable Braille display at no additional cost. There is no printing cost. There are no large books to have to tote around. The only costs that are involved is the cost of the assistive technology and the cost of the Braille display. Which, and since we're mentioning that, I'm going to show you this right real quick. So this is a page on the American Printing House for the Blind. They actually recently released a new product they call the Orbit. It's a new refreshable external Braille display. It supports being connected by USB or by Bluetooth. This is by large the least expensive Braille display that's ever been put out there. I believe the cost is somewhere around $500 that they're asking for this, which compared to, let's say, a Focus 40 from Freedom Scientific, you can pay $1,400 for that. So less than half the cost of what you'll find on many, many other refreshable Braille displays. When I was at the International Technology and Persons with Disabilities Conference, I actually saw a refreshable Braille display that was $4,000 that also functioned as a note taker, but incredibly expensive. So it's great to see that American Printing House is getting out a much less expensive refreshable Braille display. That way users who have access to like an iPhone or a computer with JAWS or NVDA can pair that up with that refreshable Braille display and have access to almost free accessible math content. So back to the other page here. Convertible into alternative formats such as SVG, PNG, etc. So this actually we'll talk a little bit more about when we get to the Benetech stuff, the MathML cloud later on. But you can take MathML content, and that can usually be converted pretty readily into other formats. So if you would rather it be an SVG image or a PNG image, or if you would rather, if you'd like to convert it into LaTeX, you can do that. So it just tends to be easier to convert things from MathML. So the second technique that you tend to find used for delivering online math content is the alternative text put on an equation image. So I have an example of that here. This is a picture of a matrix that has alternative text applied to it, and this is alternative text that was generated from the same code, the same MathML code that was used to create that image. So I had MathML for this matrix that I was able to convert into a PNG image, and I was able to convert it into a text description. And so combining those two things together, there's that embedded image on this page. So you can see the matrix, and if you're using a screen reader, you can actually hear it read that out. So I'll go ahead and have JAWS play that here for you so you can hear it.
Graphic upper I1 equals start 1 by 1 matrix first row 1 end matrix comma upper I2 equals start 2 by 2 matrix first row first column 1 second column 0 second row first column.
So that's it, just reading out that little itty bitty matrix that it's got going on there. So some of the benefits of going this route is that it's consistent across browsers. So MathJax is also, going consistent across browsers. But if you're using pure MathML content, just straight up MathML that has been embedded into a web page, that actually can vary in the way that that will appear depending on which browser you're using. Some browsers flat out don't support embedded MathML content being directly embedded into a web page. Pretty much every browser supports an image format, or well, I can't think of one that doesn't support an image format and alternative text. So this is something that's going to be supported across all different browsers. It's going to be supported by all assistive technologies that have the ability to interact and read alternative text descriptions. And again, supported by all browsers. So those are just a few of the benefits that I've got put down on here. So then I've got this section under here that I call the Braille disadvantage. So there is a really big disadvantage to going the route of using an alternative text image with a description. And that is, what that is that, so with a MathML equation, if you have a refreshable Braille display and a compatible assistive technology, so that assistive technology will display that equation in Nemeth Braille, which is Braille Math, on that refreshable Braille display. Well, if you're using an image with an alternative text description of the equation, what the screen reader is seeing is the screen reader is not seeing numbers and symbols. The screen reader is seeing words and characters. And so it's essentially like giving a non-disabled sighted user the equation 1 + 1 = 2, but spelled out. O-N-E, P-L-U-S, O-N-E, E-Q-U-A-L-S, T-W-O. Okay, yes, technically that you do have that equation. You are hearing it out. It is being read out correctly. The problem with that is it's much, much less efficient for you to read that. It takes you longer. There's more to it. If it's a very long, complex equation, that description is going to get very long and very drawn out. And so it's just not as efficient. It's not as usable as having that actual MathML content that will display as true Nemeth Braille math. And so I've got just examples here on the page that you can see. So there's this one equation, x = fraction (-b plus or minus the square root of b squared minus 4ac over 2a), math content. So, and then underneath that, you can actually see that equation being listed out as words. So just imagine if every time every equation you were working with was listed as words rather than as numbers and characters, how much less efficient that would make you in working with the math content. That's the problem that blind low vision users have to deal with when all they have access to is images with alternative text descriptions. So we'll go ahead and move on to the next page here. And so this next page is the LMS comparison. So I've, over my time here at the University of Montana, I've had the opportunity to play with all four at one point or another of the four big leading learning management systems: Blackboard Learn, Canvas, Desire to Learn, and Moodle. And so Moodle, Canvas, and Desire to Learn now have all set it up to where they now use MathJax. So equations that are generated using whatever tool. So with Moodle, for example, they have their own equation editor that's in Addo. In Canvas and Desire to Learn, they have their own equation editor functionality. But in all three of those platforms, whatever you create using the equation editor will be rendered as MathJax. So it'll, again, look the same on all the different browsers. It'll be responsive. It'll have those other benefits that MathJax provides, like copying and pasting and zooming. That hidden MathML layer will be there. So assistive technology users will be able to use whatever functionality their particular assistive technology provides, again, like the Math Viewer in JAWS, or be able to read it on a refreshable Braille display in pure Nemeth Braille math. The one exception to this is Blackboard Learn. Blackboard Learn actually does not do it that way. Blackboard Learn, their equation editor is from a company called Wirus, and you technically can get the Wirus equation editor. I may be pronouncing the name incorrectly, but that's because I hear it pronounced by JAWS all the time, and JAWS never gets things right. So you can get the Wirus equation editor in Canvas, Desire to Learn, and Moodle, but it isn't what comes in them as the default. In Blackboard Learn, the Wirus equation editor is what comes as the default. And the Wirus equation editor does use the other route of doing alternative text tagged images for equations. And so with Blackboard Learn and the Wirus equation editor, you have this issue where, yes, you are able to read out the equations. It does tell you what they are. But if you're somebody who especially needs that refreshable Braille display, you're going to find yourself having trouble dealing with that. I will also mention that we've had the opportunity to actually meet with a rep from Wirus and have been in collaboration with them on hopefully moving them forward on this. They have good reasons for wanting to stick with this. You know, it's what's already there, so they don't necessarily want to go and change it if they don't have to. It is more widely available, so whether you're using Narrator or NVDA or Screen Access, you name it, pretty much every assistive technology that is out there will have that ability to work with that alt-tagged image versus MathML content, which tends to be really only supported by popular, widely used, and normally more expensive assistive technologies. So that's just a little table there that you can see which LMS uses which technique. Again, Canvas, D2L, and Moodle, they all have now gone the MathJax MathML route. Blackboard Learn, they're doing the alternative text image route. So we'll move on to the next page here. Alrighty. So, math at the University of Montana. Okay, so we have been working for the past several years now trying to come up with what our process is going to be for how we provide alternative formats of math documents. We've looked at several different products, and we've been working with our math faculty to try and determine what's going to work best for everybody. We don't want to disrupt the workflow for the instructors. We, are under budget constraints. We don't have a lot of money to spend on really expensive, really elaborate applications. We have people who are authoring their handouts in LaTeX or in Microsoft Word. So we kind of have two different use cases there that we needed to deal with.
Aaron, can I interrupt just for a second?
Okay.
You have a debugger open on the bottom part of your screen. Can you just, the inspector just opened.
Really? Did it go away?
No, it did not. There. It altered, but it didn't go away. There, it's gone. Thank you. Sorry for the interruption.
Yeah, no problem. So those were just a few of the requirements that we had in trying to come up with what our solution for creating accessible math handouts is going to be. So that was what we needed. So what we considered, one of the first products that we really were looking at was a product called Empty Reader. Empty Reader, it's from an organization, they call themselves the Empty Project. They have multiple parts to Empty Reader. So there is the Empty Reader, which has the ability to OCR, to perform optical character recognition scans of paper math documents or textbooks, and it will attempt to convert them into HTML plus MathML. It also has the ability to import LaTeX source documents and convert those into HTML plus MathML. It comes with two companion applications, one called Empty Editor, which can be used with Empty Reader. So essentially, you could take a paper math handout and scan it into Empty Reader, and then open that up in Empty Editor and edit it, any parts of it that may not have scanned correctly. And then the third application is called Chatty Empty, which is essentially Empty Editor, but designed in a way that makes it compatible for use as a screen reading software. So there were essentially three different applications that were part of that. So there were some advantages to Empty Reader that made us consider it. So support for input via OCR. It was a product that was actually specifically marketed for what we were looking for. They were marketing to higher education clients, saying this is a tool that can be used to provide those accommodations. The fact that it included an accessible math editing application was something that was a pretty big incentive. And then this last one here I've got is just that it can be scanned in via Empty Reader and then subsequently edited with Chatty Empty or with Empty Editor, depending on which one you needed to use. So there were a lot of disadvantages to going with Empty Reader as well. And I don't know if Nicholas Voneson managed to join in on this call, and he's one of our math faculty. But he actually really did some in-depth evaluations of Empty to determine, is it really going to meet the needs of the math faculty? And in his judgment, it did not. And he had a lot of very good reasons for that. And so I've gone ahead and included those here. So some of these are from me. Most of them, though, are from Nicholas. So OCR-based input is highly susceptible. There may be a typo there. To getting errors. So that is essentially what happens with anything that uses optical character recognition. Is sometimes it'll get really good scans, sometimes it'll get bad scans. It depends on the scanner. It depends on the source document. A lot of things can really impact how an OCR scanned document will turn out. It couldn't handle the LaTeX title command. So what seems like to me it would be a very basic command. Can't handle enumerated lists. Couldn't support matrices. It missed out on a lot of standard symbols. So for example, there's this code here that you can use to typeset an arrow. It didn't recognize that. It does not consistently recognize commented out code within the source file. It had very limited documentation, and it didn't have a lot of active development. When Nicholas was taking a look at this, at that point in time, there had not been any updates to INFTY since 2014, and this was maybe 3 or 4 months ago that he was looking at this, so it had gone nearly 2 years without any updates. I actually was on there just the other day in preparation for this presentation and found they did finally release an update just in the month of October. It's a minor update, so maybe they're working on a larger new release that will drop soon, but at least as it stands right now, they had almost a 2-year window there in which they didn't put out any updates. And then when they finally did, it ended up being a rather minor update. So another product that we were looking at was LaTeX ML. So this is a tool that is just specifically its purpose is to take LaTeX documents and convert them into HTML plus MathML. Some advantages to that, so you didn't have to use OCR on it for starters. So you did tend to get higher quality results from that because you didn't have any of the OCR-based discrepancies that would happen. LaTeX, is widely used by the math and science community. So the input you're using for this application is what the folks who are creating the content are actually using for the most part. So we didn't have to, wouldn't have to require anybody to use another product that they aren't familiar with. They can go ahead and create their LaTeX in the manner in which they're used to doing it. It's free under Creative Commons license, which these days in higher ed, free is always a good thing. Active development. So they actually they welcome contributions to the project here. So this is almost like an open source project under a Creative Commons license. And so anybody can contribute to it. So it's got a lot of active development, very thorough documentation. And then some of the disadvantages to it. So it's complicated. Excuse me. So it's complicated. If you aren't familiar with working with LaTeX, then you may find yourself having trouble getting this to work. That was one definite disadvantage for us, because typically people who are going to be, creating alternative formats aren't, going to be necessarily math professionals or have really strong backgrounds in math. And so needing to know how to work with LaTeX was definitely a hard pill to swallow. It's difficult to edit post-conversion. So, once you've converted it, then it's HTML plus MathML, and you can edit the HTML plus MathML, but it is harder to deal with editing it after it's been converted compared to INFTY Reader, where you import it into INFTY Reader, and then you can edit it in INFTY Editor. Requires vanilla LaTeX. This was definitely one of the things that Nicholas pointed out here is, so there are lots of different packages, lots of different customizations that content creators can do with LaTeX, and a lot of that more customized coding isn't going to be recognized by a program like LaTeX ML. And so they used, the term he used was vanilla LaTeX. So an instructor who has a student who will need to get an alternative format of this may have to do at least a little bit of tweaking to their LaTeX source document to make it more plain, more in line with just standard LaTeX that this program would be able to work with. According to the documentation on its website, it still is missing implementation for quite a fair few LaTeX packages, which probably ties into this issue of having to use vanilla LaTeX. It's just that there are still a lot of packages out there that it doesn't support. But, with it being Creative Commons and open to contributions, hopefully that's something that'll get improved over time. No ability to convert documents where LaTeX source was unavailable. So essentially, if you've got a math textbook, this program isn't going to help you with that. There is no OCR functionality to it. So unless you have the original text source document, then your hands are kind of tied when it comes to this application. So math type. MathType was another product that we considered here. So for those of you who are not familiar with it, MathType was created by a company called Design Science. It integrates with a lot of different applications. So it can integrate with the iWork suite on Apple computers, the Microsoft Office suite. It can work with Maple, with Mathematica. Lots and lots of different applications will work with MathType. MathType allows you can create, it has a WYSIWYG editor, almost like what you see in a learning management system, where you can click the buttons to put together your equations and then put them into like a Word document or a PowerPoint slideshow. You can work with LaTeX directly. If you have a LaTeX equation, you can put that into MathType and then save that into a program like, say, Microsoft Word. If you have MathType and MathPlayer, the MathPlayer plugin, you can actually get equations reading out in programs like Microsoft Word and Microsoft PowerPoint. So it provided that additional benefit as well. Let's see here, just make sure I covered all these benefits. One other definite advantage to this too is, I mean, we did have some math faculty, math instructors who were creating their documents and their handouts and their course materials in Microsoft Word. And so with MathType, you can just essentially hand that to them and say, here, you just still make your documents in Word just like you're used to. MathType puts a little menu, adds another ribbon to the ribbon menus in Microsoft Word that says MathType. And so if you just use that to build the equation instead of Word's equation editor, then those are equations that can later be converted to MathML or provided, you know, in the DOCX file to a student who's got MathType and MathPlayer, and they would be able to read those equations out using their assistive technology. A few disadvantages to going with MathType is MathType itself is actually not accessible to users of screen reading software. This is not uncommon where programs that promote accessibility are not in fact themselves accessible. I've gotten a kick out of how many times I've come across this kind of thing. It can't take a whole LaTeX document. So I mentioned earlier that with LaTeX, you can literally create the entire document. The appearance of it, the layout, the text content, the math content, the formatting, almost the entire thing can be written in TeX. Well, MathType won't work with all of that formatting type information. It really only deals with the TeX equations. In order for those documents to be accessible to a user of assistive technology, or at least to be accessible to the widest range of users of assistive technology, that document has to then be saved as HTML plus MathML from within MathType. It's not too hard to do. It's just that in order for most assistive technologies to just easily interact with it, you need it in that HTML plus MathML. You could leave it in like a Microsoft Word format, but the problem with that is then you need both MathType and MathPlayer to be installed in order to get a screen reader like JAWS to actually read out the equations correctly in Microsoft Word. Versus if it's just HTML plus MathML, a lot of assistive technologies will work with that just fine out of the box. It doesn't require any plugins or anything like that. And one last advantage to this too is that it costs a lot less compared to InfyReader. I mean, it did cost more than the LaTeX ML because that's free, but it was $57 for a single license of MathType. So if you give each math instructor who's creating their documents and handouts in Word a copy of this, it's only $57 for each one, which seems reasonable. All right, so what we chose. So we ended up going with kind of a multi-pronged approach here. So there clearly wasn't one solution that was going to solve all the problems in the world. So the LaTeX ML wasn't going to be able to deal with those Word documents. MathType wasn't really going to be able to deal with those full LaTeX documents. InfyReader had all these gaps in its support for LaTeX that really deterred us away from it. And so the approach had to be kind of multi-pronged. So one is that we purchased multiple licenses of MathType for use here on our campus, and those are available upon request to math instructors who would like to have access to it. So anybody can contact ATS and get access to that, anybody who's a math content creator. So we have we have math type available for those folks who are creating their handouts in Microsoft Word. And then we're going the LaTeX ML route for those documents that are authored completely in LaTeX. And so that's what will be used for that. Again, the downside to that is that that particular approach does put a little more of the onus on the instructor, in that the instructor will have to, make vanilla their LaTeX code. 3, e-texts that include MathML will be requested from publishers when available. More and more publishers now really are getting on board with providing EPUB versions of their textbooks upon request, and EPUB supports having MathML or MathJax embedded into it. So you're seeing more and more textbooks that are now available upon request in a format that includes accessible math equations. I believe Pearson is one of the big ones who have really done this, where all of their new textbooks now can be requested in EPUB with MathML. And then 4, MathML compatible assistive technologies were purchased for use here on our campus. So we have a site-wide license for JAWS. JAWS is kind of the official screen reader that we use here on campus. We also have plenty of Macs floating around. All of those Macs have VoiceOver. Both JAWS and VoiceOver support interacting with that MathML content. And then we have another tool that's for folks with print disabilities but aren't necessarily blind or visually impaired, called Read and Write Gold. Read and Write Gold also has the ability to read out those MathML equations correctly. So a multi-pronged approach, but a good way to try and cover all the bases. So math type, if you're used to building your documents in Word. LaTeX ML, if you're used to building your documents in LaTeX. Textbooks, when available, we're going to request those MathML design textbooks from the publishers. And then the official assistive technologies that we've purchased here are all ones that support that MathML content. Okay, onward and upward here. I'm just going to check the time. Oh, 10:43, that took a while. Okay, so JAWS. Now we're going to start talking about what are some of the specific updates that we've seen in some assistive technologies. And I'll try and pick up the pace a little bit here, everybody, so we don't go too far over the time limit. So JAWS is amazing just how much they have improved their support for math content over the past 2 years. So JAWS 18 was just recently released. They really started beefing up their support for math content back in JAWS 16. So with the release of JAWS 16, they introduced the ability to read out MathML equations in speech. In some subsequent minor updates to JAWS 16, they added additional functionality like a feature called the Math Viewer that allows you to navigate by term or by expression. So for example, if there's a fraction, 3 over 5x, then you can interact with that fraction and set it to focus only on the denominator and only read the denominator. Whereas when it first came out, it just read out the equation essentially in one whole fell swoop. Some updates to the Math Viewer that came out later on in JAWS 16, they added synchronized focus highlighting. They made it to where the Math Viewer visually displays up on the screen, so if you're working with a tutor, they can visually follow along with what is currently being read out by JAWS. So that was a really great feature. Make sure I've got all that there. Later on, when that first came out in JAWS 16, it only worked in Internet Explorer, and it only worked with those equations that were coming out of MathJax. Interesting. Not entirely sure why it was like that, but so again, with some subsequent updates to JAWS 16, they extended that out to where it now also is compatible with Firefox, and it will work with pure MathML equations too. So if I just drop a MathML equation into a web page, that equation will be read out correctly by JAWS, whether MathJax is involved or not. So then in JAWS 17, which came out October of last year, about halfway through with version 22.11, 17.0.2211, they dropped the big one. They introduced support for reading those MathML equations on an external Braille display. So any equations that were already reading out by JAWS with speech, just after that update, were now also available to be read in Nemeth Braille on a refreshable Braille display. So it didn't require any changes. There was no need for Braille style sheets or any of that kind of thing. It has some good functionality for Braille users. So for example, it has focus highlighting, Braille focus highlighting. So a Braille character consists of 6 dots, 3 on the left, 3 on the right. They're stacked vertically. Well, a lot of refreshable Braille displays will actually have 4 and 4, 4 on the left, 4 on the right. And those bottom 2 dots can be used for things like a position indicator. And so when you're reading a math equation in Braille using JAWS, those 2 bottom dots will track along with JAWS to show you, which part of the equation is currently being focused on at that particular point in time. And that highlighting is synchronized with the highlighting that occurs visually on the page. So if you're a student reading it in Braille, you have a tutor who's watching what's going on the screen. You both are able to follow along and know where each other is at. Freedom Scientific, they also put out, lots of updates for Braille device drivers. They've got their own refreshable Braille displays, but they do support a wide variety of various refreshable Braille displays, whether they're Bluetooth or they're USB. So that's kind of the big one with JAWS. I've got a demonstration video here of what JAWS sounds like. You guys have already heard it earlier on during the presentation, so I'm just going to go ahead and move on for the sake of time. I really want to get around to showing you guys the chemistry updates in Moodle, because that's truly unique. So next one, non-visual desktop access, otherwise known as NVDA. NVDA has to be combined with a free plugin by Design Science called Math Player in order for it to have that math support. Design Science put out an update to Math Player. They released version 4.0 of Math Player, which included quite a few new features. So it can work with Adobe Reader to speak out math content that's contained within a PDF. It has a lot of different speech customizations. It can be used with NVDA's speech engine, or it actually has its own text-to-speech that it can use. So navigation in a mode that can infer the structure of math. So it's just essentially saying that the way in which you can use NVDA to navigate the equation helps you to understand the structure of the equations. You can create place markers if you want to quickly get back to another part of an equation. It also has the ability to speak out chemical formulas. So that ties into the chemical stuff we'll talk about a little bit here at the end. So Math Player Ribbon is also installed into Microsoft Word that allows you to speak out those math documents. So I mentioned that a little bit earlier, that if you want to be able to read out those equations in Microsoft Word, you've got to have Math Player. If you want JAWS itself to read it and not Math Player speech, from my experience, it seems like you need to have both Math Type and Math Player installed in order for that to work. If you just want to use this text-to-speech functionality that is provided by Math Player, then you can just hit the play button in that new ribbon that it puts in there and you're good to go. Hundreds of improvements to speech rules. Enhanced speech, including a new classroom-friendly speech style. So that's referring to its built-in text-to-speech. So if you're somebody like myself who uses a separate screen reader, that doesn't really apply to you. But if you're using the text-to-speech provided by Math Player, then it will sound more clear for you. I have a demo video here of NVDA plus Math Player in action. It's pretty short. I'll go ahead and play that. And you feel free to play it on your own computers if you'd like.
Space.
Simple fraction in MathML heading level 3 simple fraction in MathML. The fraction with numerator x cubed and denominator y heading level 3 quadratic formula in MathML. X equals the fraction with numerator negative b plus or minus the square root of b squared minus 4ac and denominator 2a heading level 3 theorem of calculus in MathML. F of x equals the integral from a to x of f of t dt heading level 3 identity matrix example. I sub 1 equals the 1 by 1 matrix 1 heading level 0 0 pause plus top plus.
So that was just 4 different example equations that were being read out there by non-visual desktop access. Okay, next here we'll move on to Microsoft Edge and Narrator. So this one is an interesting one. Okay, so I'll start this by saying Microsoft Narrator was essentially useless for an advanced screen reader user up until Windows 8. It was so limited, it could basically help you get to the JAWS website to download JAWS or to download NVDA, and it really wasn't good for a whole lot else beyond that point. With Windows 8 and with Windows 10, Microsoft really has tried to beef up Narrator quite a bit. It has now a lot of the same functionality that you will find in other screen readers, like the ability to interact with landmarks and headings, read by line, read by character, read by word, you name it. A lot of that functionality is now there in Microsoft Narrator. Unfortunately, Narrator does not yet support MathML. Microsoft Edge. Microsoft Edge is the new web browser that Microsoft has put out. It's replacing Internet Explorer, which is on its way out the door. Microsoft Edge also, no native MathML support. It is also not compatible with the Math Player plugin that used to work with Internet Explorer. So as it stands right now, your hands are pretty much tied when it comes to working with MathML in Microsoft Edge. However, if you go on to Microsoft's accessibility site where they talk about Narrator and Edge, they do mention one thing about Math, and they say that it supports the ARIA role of Math. And so that sent me down the bunny trail because I had honestly never heard of the ARIA role of Math. And so there's a description here, and I just took this from the W3C, their description of what that ARIA role was intended to mean. But it's essentially, you can apply it to like a div or something like that in the HTML code that will contain MathML or MathJax, and that's just another way of flagging to the assistive technology that this is math content. So it doesn't seem necessary, at least from my experience. I have taken MathML and just dropped it directly into a page body, and it gets recognized as math content. I've taken MathJax and just dropped that into a page body, and that's been recognized as math content. So I'm not entirely sure what the purpose of this is, since most assistive technologies that have that MathML support don't need this in order to be able to read that math content. And I actually found in testing it that it seemed to break the MathML readout in some browsers. So for example, if I was using JAWS in Firefox and I had a div with the ARIA role of math that contained a MathML equation, that MathML equation wouldn't read out with JAWS in Firefox unless I removed that ARIA role of math. Then it would. So very interesting. It seems to cause some problems. It also has the ability to create false positives. So essentially, if you add ARIA role of math to a div, anything that is contained within that div, whether it's a heading or a button or a link or a table or a text field, you name it, it's going to get called out as math content. That I think can really cause problems for assistive technology users because, so if you're using JAWS, you're used to knowing that when you hear math content, that means, okay, you can press enter and you can use the math viewer. Well, if ARIA role of math has been used to add that math content label to something that isn't actually MathML, then you'll be pressing enter on it and no math viewer will come up, even though it's calling it out as math content. So that was a bit interesting. There's probably some functionality to this beyond what I was able to determine, but as it stands right now, it seems like it causes more trouble than it helps. I have a video here just showing Narrator reading out some math content that's in that ARIA role of math. So we'll go ahead and play this.
Watch Narrator math space.
ARIA role, MathML example. 6 divided by 4 equals 1.5, math. Text example, 6 divided by 4 equals 1.5, math. Tasks 20-24 sec.
So that's just showing you what that sounds like when Narrator is reading some of that math content out. And so those were sample equations that were provided on the W3C page that described that ARIA role of math. And one of them is actually LaTeX that has the ARIA role of math applied to it and an ARIA described by property that reads out that equation. And so that's why you could actually hear Narrator reading out the equation, even though I believe visually you're actually seeing the LaTeX code. So that is NVDA and Microsoft Edge. So let's check the time here. 10:56. So we may go over a little bit. I hope you guys don't mind. I won't go quite as in-depth into these as I had maybe originally thought. So Math Support Finder and MathML Cloud, these are two products that came out of Benetech. They're incredibly useful. Marlene and I had the opportunity to help contribute to the Math Support Finder. That was really awesome. Sue Ann, I hope you're here listening to this. Oh, hey, awesome. Glad you're here. So the Math Support Finder is essentially a tool that you can use to go and look up what assistive technology platform combinations support reading MathML content. So for example, you can go to the Math Support Finder and say, I use Windows 7 and JAWS and Internet Explorer. And Math Support Finder will tell you what level of math support is provided by that particular combination. And they focus on specific access modes. There's Braille, there's speech, there's visual, and each of those access modes has its own kind of subsections. So with Braille, there's Braille, does it actually display? Then there's Braille, does it actually highlight the focus of what's currently being read out? For the visual folks, is it actually showing up on the screen? Can you zoom in on it? For speech, there's things like, is it properly reading out subscripts, superscripts, square roots, that kind of thing. So Math Support Finder is a really great resource for this if you're not sure what assistive technology combinations have what level of support. I would highly encourage people to turn to this tool for that. The second tool that they've got here is MathML Cloud. This is a handy little tool. I've got a video in here that you're more than welcome to go and check out. I'm not going to play it now just for the sake of time. But MathML Cloud can be used to convert LaTeX or MathML. I believe it can handle ASCII math as well. And it can convert that into those other formats. So for example, if I have a LaTeX equation, I can run that through MathML Cloud and convert that into an SVG image with an alt text, or PNG image with alt text, or MathML, or I can just convert that into a text description if I just wanted that. You can do it in reverse. You can take MathML and convert that back into LaTeX if you like, or MathML and convert that into SVG. There's an API for MathML Cloud that is available, so if you're a program developer, you can actually tie that conversion functionality provided by MathML Cloud into your own applications, which is a really great feature. And like I said, there's a demonstration video here if you'd like to check it out. You can do one-off conversions, so copying and pasting a single equation in and having that convert, or if you have entire source documents that contain multiple equations, you can import that and have it converted as an entire document as well. So we'll go to next here. Chemistry in Moodle. All right, last but not least, this is very, very new. We actually only got the ability to test this just a few weeks ago. So there used to be a Moodle chemistry plugin that was available on the Moodle plugins directory, and it's based off a lot of the same technology that's used by the equation editor that's built into Moodle. So MathJax, I mentioned earlier that MathJax, when you create an equation using the equation editor in Moodle, that equation is rendered out using MathJax on the screen, and that MathJax provides the non-visual MathML layer that the assistive technologies can interact with. And so this works very similar. So with the new chemistry functionality in Moodle, you get this little chemistry icon right next to the equation editor. You can click on that. There are a couple different ways you can do it. You can do LaTeX if you're writing chemistry stuff in LaTeX. That can be done. There is a specific LaTeX package that's supported by that called MHChem. That has a little bit more chemistry-specific functionality to it. So there are some circumstances in math content where things would be italicized, where in chemistry content it would not. If you're doing it with MHChem, it won't italicize that stuff that for chemistry shouldn't be, versus if you're just doing it all in LaTeX, where it may appear more like math than chemistry. But those equations that are created using the chemistry editor in Moodle, they're rendered out by MathJax, and they can be read out by an assistive technology. So I'm going to go ahead and switch to a Moodle page that I've got here. So this is just a Moodle show in where we've set up some of these chemistry formulas. I'm going to go ahead and navigate down to one of them here. So this first one here, it calls amounts. So I'm going to go ahead and play this for you and let you listen to how JAWS reads this out.
2H subscript 2 superscript O math content clickable.
So just for the heck of it,
Talk
I'm going
in
to slow
blank
this
in
down
options.
a little bit
Voices
more
sub
for you.
voice enter. Leaving tab speak tab voice tab voice rate 13 10 per enter.
So one more time, this is what that sounds
Alt
like.
tab course colon the tab math 2h subscript 2 superscript o math content clickable.
So that's an amount.
Isotopes heading
Here's
level 3
isotopes.
blank. TH plus 9227 math content clickable blank. Special symbols heading
Here's some special symbols.
blank. KCR left parent so subscript 4 superscript right parent subscript 2 superscript dot 12h subscript 2 superscript o math content clickable.
And so you may have noticed, like in that last one there, instead of saying SO, it said so. So that is something that can be adjusted by the individual user. So I can actually change my verbosity settings in JAWS so it would read that out as SO instead of as so. And then you hear it announcing subscripts and superscripts. That's just the kind of thing that, just like learning how to read math, you have to learn how to listen to the math as well. So that's just something that you'll have to practice and get used to listening to those types of chemistry formulas being read out.
Bonds heading left
Here's an example of bonds.
blank. C subscript 6 superscript H subscript 5 superscript minus show math content clickable.
So that ended with minus cho, it sounded like.
Using math heading level 3 reaction if blank reusing blank. Fay left parent CN right parent subscript 6 over 2 superscript math content clickable. Reaction if blank. Co subscript 2 superscript plus C right word 02 co math content clickable.
And so these are just all a bunch of different examples of chemistry formulas being read out within Moodle. And you'll hear at the end of each one, it's being called out as math content. That is because, you know, it's essentially MathJax and MathML that's generating this. But because it's recognized as math content by JAWS, all of its specific math functionality, again, like the math viewer and refreshable braille and navigate by term, navigate by expression, highlighting, all of those features and functionality will be available when interacting with these chemistry equations, just like they are when you're interacting with actual math equations that are in MathML. So 1103 got pretty close to the money here. So that was the last of the pages that I've put together. I hope you guys found this really useful and that I didn't go off on too many wild tangents. I'm more than happy to stick around if you guys have any other questions that you'd like me to try and answer. Marlene, if there's any questions that are in the chat, please feel free to call those out now. And thank you so much, everybody, for taking the time to listen to this. I really appreciate it. And I'm so happy to see how much math accessibility has changed over just the past few years. I, as a student, ended up changing my major because of the inaccessibility and the issues surrounding math. And, you know, that was about 3-4 years ago when I made that change. And I tend to think now that had these features been available, I may have not had to have switched my major. So a lot of development.
Right. Thank you, Aaron, very much. That was really interesting. Really appreciate all the information you shared today. There are no questions in the chat, so if anyone would like to ask any questions right now, please feel free to do so. And Sue-Ann, if you have any comments about the Math Support Finder and MathML Cloud, the work that you're engaged in at Benetech, please feel free to grab the mic.
No, I think Aaron did a great job explaining what the tools are, so I have nothing else to add. But great presentation.
Oh, thank you so much, and thank you for attending, Sue-Ann. I really appreciate it, and everything that Benetech has done.
Thank you. This was great. I learned a ton on this one as well.
Cool. Well, those pages will remain up, so please feel free to reference them and copy them or do whatever you'd like with them. I'm not copywriting them. So
great. Thank you.
And I'll also make this recording available very soon on the Montana Accessibility Interest Group website, and I will send an email out to the group in case you want to share this presentation with any of your colleagues. So that will happen soon. Are there any questions from the group? I think we're all just sitting in awe, Aaron, so.
I hope so. I hope that's what it is.
Yeah, Aaron, thank you very much. That was really informative. I appreciated the presentation.
Oh, thanks, Robert. I really appreciated the opportunity to do it. There's been so many changes over the past couple of years. It's great to get to highlight them.
Yes, so stay tuned. Aaron presents every time there's some major updates. I try and get him on to present here at the group. So we'll continue to announce that out because it's definitely a dynamic area, and we're really watching the whole STEM area for more accessible content there and ways for students to interact with that content who are using assistive technologies. So I think I'll go ahead and stop the recording. If you want to stay for a few minutes and visit with Aaron, he will be here. Thank you everyone for joining us, and we hope to see you next month. Bye-bye.
Thanks, everyone.